Welcome to AHA Math and Science. Today, we're going to solve this three blocks problem. So here are the three blocks. The length of each block is L, and the first block is sitting on the table, and it extends beyond the edge of the table by 1/12 of L. And the second block is sitting on the first block and extends beyond the edge of the first block by 1/3 of L. And we also have the third block that is sitting on the second block, and this block extends beyond the edge of the second block by 1/3 of L. And the problem is asking whether the blocks will stay on the table or fall off the table. So how can we figure out this problem? Actually, there are multiple ways to solve this problem. And one of the ways is actually to consider the torques acting on the blocks. So what is torque? Torque is the product of force and the lever arm, and it will result in rotation of an object or tends to produce rotation. And the calculation of torque is usually complicated because it requires us to know the lever arm and also involving sometimes the angle. Instead, in this case, we're going to consider another method, which is much more straightforward. And this method is based on the concept of the center mass. So what is center mass? It's a hypothetical point at which all the mass of system objects can be thought to be concentrated. So it's a hypothetical point. The point does not actually exist, where you can think the mass of the whole system, every bit of material can be thought to be concentrated on this point. To give you an example, let's think about a disk, or this could be a pie, or or a circle, or a pizza, which is a circular shape. So where's the center mass? Where's the point which we can think that be used to represent the whole disk? Well, in this case, the disk is uniform, so it will not be surprised to see that the center mass of this disk is at the center, which is the geometrical center. So the center mass of a uniform disk is at its geometrical center. What about we have a disk that is slightly different? In this case, the left half has a lower density, but the right half has a high density, so it's more dense on this side. So what will be the center mass? So the center mass of this non-uniform disk most likely is going to shift to the right. So the center mass is going to be more or less here. And so for a non-uniform disk, it's going to depend on its mass distribution. How exactly the mass is distributed? It tends to locate it on the more dense side. Or sometimes we could have an arbitrary object. For example, if you have a pie and the upper right corner is eaten, and then the center mass of the remaining parts would be kind of more located to the lower left corner. So the center mass can be actually kind of figured out. And in fact, there's an exact equation we can use to figure out the center mass, which is given here. So in this case, we just have to think about this object is made of many bits of materials or particles. Each particle has its own mass, its own position. So we just have to multiply the mass times the position of each particle and then just kind of sum it up. So here is basically m1 times x1 plus m2 times x2 plus m3 times x3, and etc. is summing over the mass times position of each particle, and then just divided by the total mass, which is m1 plus m2, etc. This is going to be the method we can calculate the center mass. So how can we apply this concept to solve this three blocks problem? So here are the three blocks. So in order to figure out whether the blocks will fall off the table or stay on the table, we just need to figure out the center mass of this three block system. So where is this center mass? And then we can compare the location of the center mass to the edge of the table. So the edge of the table is right at here. If the center mass is to the left of the edge of the table, then the blocks will stay on the table. Otherwise, the blocks will fall off. So now the problem becomes how we can find the center mass of this three block system. So the mass of each block is the same. So we can just assume that m1 equal to m2 equal to m3 equal to m, just use M to denote the mass of each block. Next, we need to figure out the position of each blocks. So in order to figure out the position, we have to establish a coordinate. We can call it X. And this coordinate system requires the choice of origin. Here, we're going to choose the left edge of the first block, the bottom block, to be our origin. We can call it X equals 0. Now we are ready to figure out the position of each of the blocks. So for the first block, we can use a point to represent it. And this point is located at the center of the block. So in other words, this point is 1/2 of L to the left edge of the first block. So X1 can be easily figured out. It's just L/2 to the left edge. What about the center mass of the second block, X2? So X2 is located L/2 to its own left edge. So from here to here is L/2. But we have to take into account the shift. The second block is shifted to the right by 1/3 of L. So we have to add this shift to the 1/2 of L to figure out X2. So X2 is L/2 plus 1/3 of L is equal to 5L/6. Now we can also figure out the position of the third block, which is X3. So X3 is at here. It's L/2 to its own left edge. But now we have two shifts that we have to include. One is this one, that's L/3, because the third block is shifted by 1/3 of L with respect to this edge, the edge of the second block. And then this first shift is also 1/3 of L. So taking into account these two shifts, we can figure out X3 is L/2 plus L/3 plus another L/3, and it's equal to 7L/6. So here are the three positions. X1 is L/2, X2 is 5L/6, X3 is 7L/6, and the mass is the same. It's just M. So now we are ready to plug in these values into this equation for the center mass, and then we can figure out the M is all the same. X1 is L/2, X2 is 5L/6, X3 is 7L/6. On the denominator, it's just 3M, and the M's all cancel out. So we just left with L/2 plus 5L/6 plus 7L/6 and divided by 3. 5 plus 7 is 12. 12/6, that's just 2. 2 plus 1/2, that's 2.5L. And 2.5L/3. And we can write nicely in terms of a fraction. So multiply by 4 on both top and bottom. 3 times 4 is 12. 2.5 times 4 is 10. So it's 10L/12. So this is the center mass of our three blocks. So we can label the center mass, and this 10L/12 is measured with respect to the origin, which is this edge here. So that's 10L/12. So how does this compare to the edge of the three blocks at the table? So here is L/12, and therefore from the origin to this edge of the table must be 11L/12. So therefore the total add up to just a whole L. So it's very clear that the center mass is smaller than the 11L/12. In other words, the center mass of the three blocks system is located to the left of the edge of the table. So based on our earlier discussion, these blocks will not fall off the table because the center mass is located to the left of the edge of the table. So this method of using the center mass to actually figure out whether the balance can be achieved or not is much more efficient and also straightforward compared with the calculation of the torques. Because here, everything is just algebra. There's no need to consider forces. The only thing we need to know is the position and the mass of each of the blocks. And so the calculation also is straightforward, and we were able to determine whether the blocks will stay on or off. What the problem initially seems like it's kind of difficult to guess whether the blocks will stay on or off the table. So I hope you have enjoyed this video, and thanks for watching.